just to reiterate, the theme for this year's seminar series has focused on early career scientists, and the guest speakers that we've had over the course of this year has not disappointed. We've had the opportunity over the course of the year to learn about a range of cutting edge assessment science topics, and I would like to take this opportunity to thank all of our invited speakers for sharing their work with our NOAA science, our NOAA stock assessment community. With that, I am very pleased to introduce our final speaker of 2022, Dr. Ming Sun. Dr. Sun is a postdoc at Stony Brook University working with Professor Young Chen. Ming's research interests include stock assessment, data-limited methods, management strategy evaluation, and international fisheries management. So with that, I'm going to pass it over to you, Ming. Thank you for being here today.
Yeah, right. Thank you very much, Lisa and Christine, for the invitation and the introduction. So my name is Ming, and I'm a postdoc at Stony Brook University. So the topic of my presentation today is the status and management of mixed fishery, global synthesis. So before we really talk about the presentation, so I want to start by a brief mixed fisheries fundamental. So basically, what is mixed fishery? So there's a definition by Kell et al. 2004 that I like the most, which is very straightforward. So mixed fishery are basically referred to fleets and fisheries that harvest multiple stocks, and the stocks harvested by multiple fisheries. So on the left side here, there's a very good illustration of a typical type of a mixed fishery. So we can see there are multiple groups of gears. We can see at least 4 to 5 types of gears here, and they're operating in the same area of water. And we can also see more than a dozen of species being affected by the fisheries. And in many parts of the world, mixed fishery is being called with other terms. So I think mixed fishery is more like a popular term in Europe. So, but in the United States, people have been talking about multi-species fisheries because in United States, many species are managed under a species basket or species complex that share a certain management measures or something. And other than that, we may also have multi-stock fisheries, which may refer to the same species, but could be divided into several separate stocks in a certain space. And beyond that, we also have multi-sector fisheries that may try to emphasize the different fleet or different participant in the fishery. For example, fisheries with different permits, fisheries from a fleet with different permits of fleets from different countries. And also they're also called multi-fleet fisheries. So, mixed fishery or multi-species fisheries can be manifested by simply the catch, because catch can consist of many species in mixed fishery, as we've seen in this Cicero photo down here. We can see fin fishing there, we can see crustaceans there. So it's a very typical catch of mixed fishery. So we may wonder why mixed fisheries could occur. So it's kind of not hard to understand, because naturally in the marine ecosystem, many species, they could overlap either in space or time. So it's very hard to separate them at all. And at the meantime, as we've seen in this figure up there, different fishing fleets, particularly when they are using different gears, they could also overlap. They could try to operate in the more productive area to get more catch. And with all these conditions, the last condition, but most important one here, is that fishing selectivity is a process that far from perfect or far from being expected. So fishing selectivity is mostly a process that dependent on size instead of species. So we may catch many different species of similar size, but it's very hard to specifically target completely only certain species. As we may see in this WWF photo down there, it's a very good illustration of a very clean single species fishery, which catches mainly, I think, redfish. But it is quite rare actually, because most fisheries in the world do not have very clean catch at all. And what is actually the difference between the single species fishery and the multi-species and the mixed fisheries we talk about today? So let's go back to this figure here. So in this figure, we can see a dozen of species, and they're connected by different arrows. Like basically, they would have many complex interactions through trophic interaction or predation or ecological competition over the same niche. So this is what happens within the marine ecosystem. But when we have fisheries with different gears, we know that different gears would have different selectivity patterns, normally modeled with different selectivity curves. So they would have different chances to catch certain species. Well, for one species, they may also have different chances of being caught by certain gears, and the probability can differ quite a bit. So when the two types of interaction, the biological interaction and technical interaction overlaid, this can make a mixed fishery extremely complicated to model and to manage compared to single species fishery. So why mixed fishery could be an issue in some part of the world and why there are concerns. So basically, we have seen many ecological and management risks due to mixed fisheries. So first of all, we all know that traditional fisheries management and assessment are mostly built on a single species perspective. So in that perspective, we would treat different stocks or different species separately as individual management unit. And in most cases, we do not consider the interaction because it's naturally very hard to model, or simply we do not have that information. And that would result in the consequence that we can come up with sometimes incompatible or even conflicting single species management advice. For example, in the North Bay, most species are managed with single species catch limit. But when they are involved in a mixed fishery, we could end up find that some of the single species catch limits are not viable at all because we could have some species with much lower catch limit, which constraining the fishing opportunity for other species, resulting in a choking issue for that fishery. In addition to that, other than the target species with catch limit, the mixed fishery could also affect some non-target species in the mixed fishery. But some of the non-target species, they may have very important ecological roles, but they receive relatively much less management attentions. That could cause some very big ecological risk. And many of the non-target species are treated sometimes as bycatch species and end up being discarded overboard. So this could result in some fishing mortality that's very hard to account for. And it is actually a waste of fishing effort and sometimes food in many parts of the world. So with all the knowledge of mixed fishery and with these ecological and management risks, we believe there are several questions should be answered for us to better manage and assess mixed fisheries in the future. So first, we should understand what are the overall characteristics of mixed fisheries worldwide. So what are their features? What do they have in common and what differences do they have? So secondly, we should understand how mixed fisheries are currently managed and assessed in different parts of the world. So what approaches out there are available and are functional, most of all. And third, we need to understand how much do we know about mixed fishery and how much research efforts we have devoted into that field. This will determine what topics should we look further into in the future. And last but not the least, we need to understand what are the key factors that could contribute to a better management performance for mixed fishery, or in other words, management success for mixed fishery. So in order to answer all these questions, we conducted knowledge synthesis for mixed fisheries worldwide, and we selected roughly 24 of mixed fisheries around the world. And we reviewed their management plans, their assessment reports, and their relevant publications associated with these fisheries. We tried to use the data of 2019 because that was the last year before the pandemic, and after which many fisheries have been severely disturbed. And you may see that we have selected many fisheries from the United States, from Europe, and Australia. And we also try to include several fisheries from the developing world that have very distinct management system to other parts of the world. Okay, so with these fisheries, we try to understand the following aspect, as we mentioned earlier. So the first part is to understand the characteristics of mixed fisheries. So to start with, we first map the locations of these fisheries on the map, and we look at their types. So basically, we were able to group them into 5 major types, primarily based on the species group they target. So here we have demersal mixed fisheries that catch mainly groundfish species. And we have pelagic mixed fisheries that catch pelagic species. And we also have reef fishery in the tropical area to catch reef species. And we also have shrimp fisheries, mostly catch only a variety of species of shrimp. And beyond that, we also have one interesting type here, which is multi-sector fishery. As we mentioned, multi-sector could be defined into different forms according to the management agency. So here, multi-sector fisheries, in some cases, they could include more than one type of mixed fishery. For example, some multi-sector fisheries, they could have a demersal fishery and a pelagic fishery. And sometimes they could have multiple fleets. Sometimes they have multiple permits. So it's way more complicated than the other types. And the second thing we look at for this mixed fishery is we look at the size of these fisheries, basically by looking at the annual catch volume. So overall, according to this violin plot down in the corner, we can see that most of these cases we reviewed have an annual catch limit, catch volume below 500,000 tons, or even below 250,000 tons per year. So we have very small mixed fisheries some part of the world. For example, in Australia, we have the smallest case, only roughly 67 million metric tons, sorry. And at the meantime, we have very big mixed fisheries, which is the one in China, a provincial mixed fishery, and the one mixed fishery, I think is Bering Sea and Aleutian Island groundfish fishery, both roughly at 2 million tons. So overall, the size of mixed fishery can vary a lot. And the third thing we look at is the gears composition in mixed fisheries. So we know that according to the definitions, mixed fishery normally involves multiple gears. So in all the cases we reviewed here, except for 2 cases in Australia, all the other mixed fisheries have at least 2 types of gears. And the most widely used gear in mixed fishery we have is trawls. This is quite easy to understand because trawl is not a quite selective gear compared to other type of gear. And trawls are followed by hooks and lines and gill nets. And one thing I want to highlight that although some of the mixed fisheries, they may only have one type of gear according to our classification, but this classification is actually made according to the FAO standard. So the fishery could actually involve several types of different trawl variants, but we all classify them as trawls. And according to our calculation, the average number of gear types used in these fisheries is 2.87, so which is obviously way higher than 2. And after gear composition, we try to understand the complexity in catch composition of mixed fisheries. So to measure the complexity in catch composition, we use 3 types of ecological indicators. So the first indicator we use is Margalef index, which is used to measure the species richness in catch. The value normally ranges between 0 to 3 and representing low to high species richness. And the second indicator we use here is the Shannon-Wiener index, which reflects the diversity in catch, and ranges mostly between 0 to 2.5 and representing low to high catch diversity. And the third indicator here we use is the Pilo index. It measures the scale of mixture, and the range of Pilo index is strictly between 0 to 1. with 0 representing no evenness in catch and 1 representing complete evenness. So which means that if a pillow index is close to 0, the catch could be mostly regarded as a single species catch. And when pillow index is close to 1, we could imagine a fishery, for example, catch 5 species, and each of the species account for 20% of the weight in catch. So that would close to a complete evenness. So overall, if we look at the aggregated distribution of these indicators according to this violins plot above, we can see that particularly for the pillow index, evenness, and Shannon-Wiener index, diversity, the median and mean value are pretty high. For pillow index, both values I think around 0.7, which is the relative high value here. So this indicates that the catch composition of mixed fisheries can be really complex, although the species richness are overall pretty low. And we also noticed that there is a very significant case-specific and region-specific difference. Okay, so with these results, we may imagine there could be some patterns related to the catch composition, probably due to other factors. So here we conducted a little bit more statistical analysis by looking at different factors influence to the catch composition. So we aggregated the calculated indicators of all the mixed fisheries, first by region in figure A, and then by the fisheries type in figure B. And we also sort all the calculated indicators by latitude to understand if there's a latitudinal pattern, because obviously in the marine ecosystem, of high latitude, we may normally see a lower diversity compared to the tropical marine ecosystem. And in figure D, we sort the estimated indicators by the size of the fishery, by the log transformed total catch volume. So what we see here, so first of all, according to figure A, we find that along with some statistical analysis, we find that region is actually not an influential factor to catch composition because none of these differences were significant. And for figure B, we find that type of fisheries is only influential to the catch diversity, which is the blue bar here. And we noticed that reef fish mixed fisheries have the most diverse catch composition compared to other mixed fisheries, while pelagic and shrimp mixed fisheries have relatively lower diversity. And in figure C, none of this trend, latitudinal trend, was significant, indicating latitude is not an influential factor. And for the size of the fishery in figure D, it's only significant related to the mixture in catch. So basically, the more fish you catch, the more evenness you get. So overall, we've noticed that the region is not an influential factor, while type and size of the fishery are sometimes influential. So after that, we look at the single species stock status in mixed fisheries. So we first try to understand the stock status measured with single species biomass relative to the BMSY reference point. So we could we use pie charts to show the proportion, and we use different color to represent different different stock status. So we have green representing the single species stocks that are not overfished, red representing overfished, and gray representing the stocks that we do not have stock status information, and mostly due to lack of data or lack of stock assessment. So overall, the biggest pattern we see here is that even within the same mixed fisheries, the single species stock status can vary a lot. And overfished stocks in mixed fisheries are quite common. And we noticed that Australia and Alaska fisheries regionally are doing pretty good in terms of conserving biomass. And beyond that, we also noticed that many of the single species stock in mixed fisheries are shaded in gray, which means data availability has been a very severe issue worldwide. We basically have seen gray in mostly every pie chart except for one here, I guess. So next, we look at the single species stock status measured with fishing mortality relative to FMSY. Basically, looking at how many stocks are not being overfished, are not subject to overfishing at the moment. So the pattern we observe here is quite similar to the biomass pattern. So we've seen Australia and Alaska also doing pretty great in terms of avoiding overfishing. And we noticed that the European mixed fisheries regionally looks like doing pretty bad in terms of avoiding overfishing, particularly for the two Mediterranean mixed fisheries, which both have more than half of the single species stocks overfished. And we also have a severe data limitation issue across the world for the fishing mortality information. Okay. So next, we try to look at the stock assessment details for these mixed fisheries. So as we conduct a review, we noticed that single species stock assessment are still primarily used for all these mixed fisheries stocks. So we here, instead of looking at all the specific models, we simply classify them into data-rich and data-limited methods based on the respective classification of different agencies. So here we can see that overall data-rich method, which is represented by the green bars, are still the predominant approaches used to assess single species stocks in mixed fisheries. And except for two stocks here, we do not have any stocks being assessed. I think the proportion of data-rich method ranged roughly from 40% to 90%, and mostly above 50% of stocks. So other than that, data-limited methods, as indicated by the yellow bars here, are still used pretty widely in many fisheries. And again, we've seen severe data-limited issue in mixed fishery because of the so many unassessed stock. So this tells us in a mixed fisheries, we don't necessarily assess all the stocks involved with similar approaches, and not to mention their data availabilities. And beyond that, we look at how the mixed fisheries sectors have been considered in their stock assessment. Here, we can see that overall, we've seen very different approaches being used in very different fisheries. But if we further classify them into different levels, we still can see some patterns here. So overall, we have the largest scale assessment, for example, which is, for example, the ecological risk assessment in Australia, the ecoregion overview in Europe, and some of the ecosystem assessment and PSA in other parts of the world. So this assessment are being conducted at ecosystem-wide. So it's very large, very comprehensive analysis. And below that, we have fishery level analysis, which is marked in blue. And they're mostly used in Europe, North Atlantic by ICES. So we've seen some mixed fisheries modeling here with different types of models. And they also offer some qualitative fisheries overview report. And further below that, we have even smaller scale multi-species level assessment. For example, for the Gulf of Mexico shrimp fishery, there is an aggregated production model analysis, which simply aggregate all the biomass of different shrimp species together to perform a production model stock assessment. But beyond all these approaches, we still notice a quite considerable proportion of mixed fisheries we reviewed here. They do not specifically consider mixed fisheries sectors in assessment at all, which leaves a very huge gap. So next, we're gonna jump to the management information of mixed fisheries. So the first step to understand mixed fisheries management is to understand what species group are being included in the fisheries management plan. So we noticed that except for the two fisheries that do not currently have FMP, all of other mixed fisheries build their management plan primarily around target species, as marked in green here. And some of the fisheries, they only include target species in the plan. But beyond that, we can see non-target species, as marked in blue, also commonly included. But the interesting thing is they could be termed differently by different agencies. sometimes they do have different considerations based on the target species status, or based on the ecological rules, or based on the specific impacts from the fishery. For example, we can see byproduct species here. We can see bycatch species here. We also have ecological component species in the United States. And we also have non-directed associated species, which is also kind of non-target species. But non-target species is not always considered. So what is even more or less considered is the protected species. They're only considered in several of these management plans. So this basically tells us to manage a mixed fishery, it is very important to define what species to be managed, but the scale of management can vary quite a lot. And the next thing we look at is what are the primary management tools used to manage these fisheries. So we simply classify all these tools into two groups. The output control that limits mostly catch, and input control focus on effort limits. So for output control, it is consistently using single species tag, which correspond to our earlier fisheries background information. And for input control, there are a diversity of approaches. So some of them are quite quantifiable, quite explicitly defined limits. For example, the gear limits, the number of permits allowed, the fishing days allowed, or other types of effort limits. However, there are also some very extensive input control measures without a quantifiable target. For example, in China, there has been a nationwide summer closure, which closed the fishery entirely for 3 months. It's very extensive, very comprehensive, but the effect is very hard to understand without quantifiable target. So next thing is quite similar to what we've seen in the stock assessment consideration. So here we look at mixed fisheries factor, how was it considered in management? So the pattern is quite similar. So we can still divide them into into 3 levels. So we have the most widely used, most big picture ecosystem-wide approaches in Australia, which is ERM. And below that, we have a relatively smaller fishery level management consideration. For example, North Atlantic, mostly issued by ICES. They have a METIA-based advice and METIA-based catch analysis to understand if the single species catch limits are actually compatible in the reality. And even smaller, we could have sub-fishery level approaches to look at either multi-species or multi-fleet perspective. For example, in terms of multi-fleet, they may look at how to allocate the catch limits between different fleets, different sectors, or between different permits holders. And in terms of multi-species perspective, so it's mostly about develop multi-species MSY in addition to single-species MSY, although the approach to define multi-species MSY can vary a lot. So the next aspect we look at is the current research development associated with mixed fishery. So to understand the research progress, we simply conducted an exhaustive literature review to look at all the publications that are related to mixed fishery in the past 6 years, since 2015. So we were able to identify roughly 250 publications and extracted more than 400 keywords related to mixed fisheries. And we then classified them by region, by case, and coded the keywords into 12 mutually exclusive topics. And they are visualized here with this heat map along with 2 bar plots. So here we can first look at the bar plots at the top of the figure, which is the keywords frequency by research topics. So we can see the top 3 mostly studied research topic in mixed fishery are management policy and strategy, modeling of mixed fishery, and bycatch, discard, and selectivity issues in mixed fishery. And we can then look at the case and regional specific bar plots on the left side. We can see that the most well-studied mixed fishery is the North Sea demersal mixed fishery, and followed by the Bering Sea and the Aleutian Island groundfish fishery in the United States. So roughly, most mixed fishery in Europe and the United States and in Australia are pretty well studied. Well, in contrast, the fisheries classified on the other part of the world are generally poorly studied with very few publications and very few keywords. So some of the mostly concerned, most frequently studied keywords for a certain fishery is highlighted here in the heat map with the dark cell here, and they're mostly concentrated in several frequently studied fisheries. So overall, we can see that there is substantial knowledge gaps and regional gaps around the world. And we've seen some of the very commonly studied topics, but we also noticed that some less studied topics could also provide very valuable insights for us to navigate our future assessment and management. For example, we have environmental consideration here, mostly look at climate change effects. We also have ecosystem consideration to explore the operationalization of EBFM. And we also have socio-economic consideration to explore the eco-viability of different management strategies for mixed fisheries. So with all this information summarized above, we try to understand how many of these factors are influential to the management success of mixed fisheries. And we absolutely understand that different fisheries could have different management goals, so they could be defined differently in terms of what is success. But to conduct a consistent analysis here, we tried to use very simple measurement of management performance here, simply based on the probability of single species stock status with biomass larger than BMSY and the probability of F smaller than FMSY, which is to conserve biomass and to avoid overfishing. So we also noticed that for all the cases we reviewed here, some of them do not have enough information or data to support this analysis, so they are excluded from the study. So the next step here is to select a suite of candidate independent variables that could be potentially influential. So we try to select these variables based on the 4 aspects we proposed earlier. So to understand, to consider the effects of complexity in mixed fishery, we incorporated number of gear types and the catch evenness, the scale of catch mixture through pillow evenness index. And for stock assessment, we look at the proportion of stocks being assessed in the fishery. And we also look at what are the scale of mixed fishery considerations in assessment. Well, for management-wise, we look at the species coverage in plans, look at the management tools, and consider also the scale of mixed fisheries considerations. And to reflect research progress, we simply use the number of relevant publications available. So these variables can be either quantitative with absolute numbers or categorical that are reflected through several independent levels. So with these independent variables connected with the 2 dependent variables, we develop a suite of regression models and identify the best fit models through a model selection procedure. So here is a simple illustration of the effects of different factors to management success. So for the effects on probability of biomass larger than BMSY, we only have one factor with significant influence, which is the scale of mixed fishery considerations in management. And for the effects on probability of avoiding overfishing, there are way more factors significant here, except for the species coverage in management plans and the pillows evenness index. So here to simply cover the key points here, we can delve a little bit deeper into the results. So we first look at in detail the scale of mixed fisheries considerations in management, and because it's significant to both dependent variables. So as we build this model with ecosystem level considerations as the base model, we notice that all the other smaller level of considerations or no considerations at all, they all have relative negative values relative to these ecosystem level considerations, indicating ecosystem level management consideration could have a significantly positive effect to management success. And so what are the other factors that could help us to better avoid overfishing, according to the last column here? So simple enough, the fewer gears used, the easier to avoid overfish. The more stock assessed, the easier we can avoid overfishing. And if we apply ecosystem and multi-species level assessment, we can easily avoid overfishing. And the output control perform much better in terms of avoiding overfishing compared to input control. So to sum up, so the single most important finding here is that ecosystem-based fisheries management in mixed fishery is a significant contributor to effective management. So above all of this, all the presentation earlier is about global overview of the mixed fisheries, but as I may say, we have focused much of the effort on the fisheries from the developed world. However, many of the mixed fisheries worldwide are distributed in the developing countries where they have very distinct management system and very unique challenges. So following this, we have conducted a national case study of China to look at the mixed fishery in that country as a representative of the mixed fishery in developing world. So this part of study has been published in this paper. So if you are interested, you're more than welcome to look at the details here. Before we get into this part, I want to briefly introduce the fisheries background in China. So China's domestic fisheries, as you may all know, is the largest domestic fishery in the world. So in 2021, it has roughly 10 million tons of national landings, which is 3 times of the United States. And it has more than 140,000 registered fishing vessels nationwide, and which is also roughly 2 times of the United States. And we need to note that this number may not be quite accurate because many of the small-scale fishing vessels in China may not be registered. And many studies have also pointed out that the commercial stocks in China's EEZ are severely overfished, and many of the stocks are still undergoing overfishing. So this is indicated by increasing number of collapsed stocks over the past decade. And the fisheries management system is also suffering from overcapacity and the lack of monitoring and scientific inputs. And overall, it's a less developed system compared to what we mostly see in the US, in Australia, or in the Europe. So these 2 parts of facts are already well known, and people have been looking so detailed into this. But there has been an anecdote going on with China's fishery that people have been talking about for decades, but there hasn't been any corroborating evidences, which is China's fishery is believed to be poorly selective and indiscriminate. People have been talking about many species being caught there, regardless of their commercial value, and they're always marketable. And there has been a wide range of gears being deployed, and they mostly have very undesirable selectivity. But these arguments are mostly conjecture and no evidence supporting this. So here we try to provide some analysis of relevant data to provide evidence to look at this issue. So long story in short, we established a nationwide database for the fishery level catch composition for China, and we rely mostly on peer-reviewed publications from the last 10 years because the official catch statistics from China has some quality issues, and we cannot conduct any high-quality quantitative analysis based on them. So roughly, the database has a very good spatial coverage of the 4 Cs and a very good representative of gear composition and the seasonal data. So I'm gonna very quickly flash through some of the key findings we have here without really digging into the details. So the first biggest finding we have is that China's fishery generally have a very low target species presence. So according to figure A here, roughly 60% of fisheries in China do not have a primary target species, which means they could accept anything they catch, and they do not really tell target species from non-target species. And the figure B shows that even for those fisheries with target species, the range of target species catch ratio can vary quite a lot, ranging roughly from 0 to 1. And the second finding we find here is that overall, China's domestic fishery has very high mixed strain catch, reflected by this pillow index. Is constantly, the regression line here is constantly over, I think, 0.7. But we've observed very weak patterns in terms of the space. So the trend here, the latitudinal trend here is not significant for diversity or for the evenness. So the third finding we have here is to look at the gear effect. So overall, the management agency in China has developed some gear regulatory types, which seems to be effective, at least in paper. So there are 3 regulatory types defined. So the first is permissible gears. They are fully allowed to operate because they have very good selectivity and very low ecological impacts. And prohibited gears are fully banned from using due to the high ecological risk. And the most interesting thing here is the transitional gears. So they also have very poor selectivity, but they are used so widely, which makes it impossible to ban them at this moment. So according to our analysis, we found that permissible gears, they are pretty good in terms of catching target species and avoiding byproduct catch. Whereas transitional gears, they could end up with very high catch diversity and very high catch evenness, and they have a very variable performance in terms of catching target species. So overall, the policy is working in paper, but enforcement is another issue. So the next finding here is associated with key commercial species. So here we zoom into 15 key commercial species in China's EEZs and look at their catch ratio, which is basically their weight ratio in catch. So according to this bar plot here, this whisker plot here, we see that individually, none of these key commercial species have high weight ratio in catch, and they're mostly, the median value are mostly below 0.25. So this means that individually, none of these commercial species could support a clean single species catch. So there's a possibility that combinedly, they could account for a good proportion in catch, but we are still talking about very complex multi-species catch in terms of very clean single species catch. So if we further look at how what gears are used to catch these commercial species. So in figure A, we see that except for 2 species here, all the other key commercial species are caught by at least two types of gears, and the average number of gears used to catch them is more than 3. So this indicates a very complex multi-gear fisheries nationwide. And if we further classify them into gear regulatory type, we can see the predominant role of transitional gear in China's fishery. So this would imply a overall very poor selectivity of the fisheries associated with commercial species. So there are lots of information from the second focal analysis on China. So the biggest thing I want to share with you here is that mixed fishery management in developing countries, they are quite complicated due to several unique factors compared to developed regions. So overall, there are very high fishing efforts and fishing pressures. And the second thing is the huge socioeconomic demands. Well, as we have pointed out a few issues in China's mixed fisheries, it is actually not necessarily a bad thing because it has provided very important aquatic protein for the local community and also provide very key livelihood for fishermen over there. So the unique socio-economic demands over there is a very big factor during the management decision making. And the third thing is more general, is that most of the developing regions, they do not have enough management and research capacities. So they would end up with very data limited fisheries, very poor enforcement, and not to mention the any use of stock assessment. So we believe at a global scale, if we want to achieve a better mixed fisheries management success, we will need to further promote trans-regional knowledge sharing to understand what works and what not. And second, for the local managers, in order to make their management effective, they will need to adjust and localize some of the solutions to better address the trade-offs between ecological and socioeconomic goals. And most important, they need to build the capacity for their long-term management. This is the only way to translate management from theory to practice. So there has been lots of information in my presentation. So this page, I will simply summarize a few take-home messages. So first of all, according to our review, the mixed fisheries worldwide, they could have some commonalities and some differences in terms of their fisheries characteristics. And many of the features are dependent on the target species they catch. So secondly, we confirm that single species approaches are still the foundation of stock assessment and management in mixed fisheries. But mixed fisheries considerations can be taken in assessment and management in a variety of forms, particularly at a variety of levels, a variety of scales, based on the management systems. They can be done at ecosystem-wide level, they can be done at fishery level, or even sub-fishery level. There are a bunch of methods to use. And last but not the least, we believe future mixed fisheries management could benefit from more EBFM and better considerations of socioeconomic factors. However, by far, we still do not have best management practices for mixed fishery defined. So there are still lots of work to be done in the future. So finally, I want to thank all my co-authors and other contributors for their expertise in some of the regional fisheries. And without their contributions, this analysis cannot be done. And thank you, Lisa and Christine, for inviting me here.
Thank you so much for your presentation, Dr. Sun. This is really very interesting. And audience, we have some time to answer your questions, so we'd love to hear them. Please type them in the questions chat box. It's over on the right side in the control panel, and I'll read them to Dr. Sun. And also, I just put the link to the NOAA Central Library YouTube channel. So if you know of someone who might be interested in Dr. Sun's work, please let them know that I'll have this recording uploaded probably in the next couple of hours. So let's go and see if we have any questions. Yes. So here's our first question. This person asks, do you think there are lessons from mixed fisheries in developing countries that could be applied to more developed countries' mixed fisheries?
Yes, I think according to our analysis, we believe several things in developing countries, which more like lessons, could be really useful. So as I mentioned in the last page, let me turn there. So the most important single thing here is to limit the overall fishing efforts and fishing pressures. As for the case of China, most of these issues are probably due to the overfishing. So if you could restrain the overall fishing effort to a moderate level, some of the issues could be gone. Yeah, this is probably the only thing we notice at the moment. Maybe another thing is that socioeconomic demands could play a very important role in decision making. Sometimes outweigh the ecological consideration by a lot, at least in developing regions. So maybe in the future, we need to better consider multi-dimensional decision-making process, and particularly when it comes to goal settings, it is really necessary to define a suite of different goals instead of only focusing on one aspect of fisheries management.
Thank you. I'm going to hold out to see if we have any more questions today. And meanwhile, I really want to thank you for sharing your work today. If you have any questions in the audience, please feel free to contact Dr. Sun directly. I believe your email was on that last page of your slides, so but there it is, yes. Oh, we just got another question. This person says, thanks so much for a very insightful and interesting presentation. Do you have any insight on the role of interdisciplinary / holistic, i.e. One Health perspective on future management?
Well, this is a really big question. I'm not sure if I'm in the position to answer that. Well, one thing I mentioned is that we definitely need to go multidimensional, because also in some of the, if we can go back to the research topic here, I think there's some fun details that we did not have time to touch on. So if you really look at this topic we summarize over here, actually there are lots of potentials to dig for many of these topics. As I mentioned, there were socioeconomic considerations, climate change effect, ecosystem consideration. So I think developing holistic approach for mixed fishery, it needs first at least incorporate all these considerations, because none of these threats can be ignored. And second thing is that we need to combine policy and science and keep a very good a connection between them, because right now we have management strategy being studied a lot, modeling being studied a lot. But I remember we didn't have that analysis, but some of the studies, they only look at one aspect instead of the connection between them. So if we can better connect modeling and management strategy, I think it could help us answer a lot of questions and help us develop more holistic approaches in the future. Yeah, I hope this answers the question.
You did a good job. You did get another compliment that just says, great talk. It's always good to hear the compliments.
Yeah, thank you.
You're welcome. It looks like that might be the last question. So again, thank you so much for coming to library seminars and presenting today, Dr. Sun. I also want to mention that this is the last seminar of the year, and it's the last one that Kristen Blackheart will be hosting. So I want to just say how much we have enjoyed working with her here at the library. And as of next month, Abby Furnish will be organizing the series. So I'd like to also welcome her, and hopefully you will also be joining us in the audience for our next presentation, which will be on the first Thursday of next month at 3 p.m. Eastern Standard Time. Again, thank you, Dr. Sun, and everybody enjoy the rest of your day. Take care.
Thank you.
Thanks,
Have a good
Lisa.
one.